Hello and welcome to the Unit 5 Section 3 video on graphing general rationals. So in Section 1 we talked a little bit about graphing rational functions, but we did it by using transformations, using the simple rational function. Well, general rational functions must be simplified to determine key features, okay? And in this section, even though we're talking about graphing general rationals, we're not actually going to graph anything, okay? That's going to be an extra credit item for you. Rather, what we're going to do is just find the features that you would need to graph, okay? If you can pick out the features that you need to graph, then you should have fairly little trouble being able to actually graph the rational itself, okay? And we'll go over the steps to produce a graph here at the end of the video. But for now, let's talk about the features that you're going to pick out of these equations. So there are 5 of them, and the first one is the horizontal asymptote. And we're going to start with that because it's got the most conditions associated with it. So you're going to look at the degree of the simplified function, okay? You're going to look at the top, you're going to look at the bottom, and really you can do it for your original function as well, okay? Because your degree is not going to change based off of your original function. In fact, I think it may be easier to find it off the original function. And we'll do that in the examples, but let's talk about what happens. If the numerator's degree is greater, then you have no horizontal asymptote. In other words, if you have the highest power on the top, and that power is higher than the one you got on the bottom, then there's no horizontal asymptote. If you have a higher power on the bottom than on the top, then your degree is greater on the denominator, which means your asymptote is y equals 0. Now, what happens if you have the same degree on the top and the bottom? Say you have x cubed on the top and you have x cubed on the bottom. They are both the highest degree. Well, then you're going to look at the leading coefficient of that power. Okay, so if you have 3x to the third on the top and 4x to the third on the bottom, then your denominator, your numerator's leading coefficient, your denominator's leading coefficient would give you 3/4, okay? So if you had 3x to the third on the top, 4x to the third on the bottom, your horizontal asymptote would be y equals 3/4. You'll see that more in the examples. Let's move on to the other features. Vertical asymptote, the value of x that makes the simplified function undefined. And it's important, you've got to look at the simplified function for this one, okay? Because what you cancel out is not going to be an asymptote. And we'll talk about what that is here in a moment. So whatever value of x that makes the bottom 0, because we cannot divide by 0, that gives you your vertical asymptote. And remember, it's for the simplified function. X-intercepts, the value of x that makes the numerator equal to 0. Okay, so just like you did for the bottom, you found the values of x that made the bottom 0, you're going to go to the top, find the values of x that make the top 0, and that gives you your x-intercepts. Your y-intercept, as always, plug in 0 for x, you solve for y. And then for your holes, you're going to find out what you canceled out on the top and the bottom. And really what you canceled out on the bottom is what we're interested in. Whatever makes the bottom 0 from what you canceled out, that is a hole rather than an asymptote, okay? So when you factor out your bottom, you're going to get 2 things. You're going to get a vertical asymptote from the stuff that doesn't cancel, and you're going to get a hole from the stuff that does cancel. Now let's go into some examples so you can kind of see how we pick these things out. And we're going to start with a fairly straightforward example. Okay, so for this example, we have y equals x minus 3 over x minus 1. Well, there's nothing to factor, there's nothing to cancel, so we're already in simplified form. So our simplified function is going to be y equals x minus 3 over x minus 1. So let's talk about a horizontal asymptote. The highest power on the top and the bottom is 1. And our leading coefficient for the top and bottom highest power variable is also 1. So 1 over 1 gives us 1. So y equals 1. For the vertical asymptote, what makes the bottom 0? Well, if we put in 1 for x, 1 minus 1 gives us 0, so we would end up with the bottom being 0 when x equals 1. For our x-intercept, what makes the top 0? If we put in 3 for x on the top, we would get 0 on the top, so x equals 3. For the y-intercept, if we put in 0 for x on the top and the bottom, we get negative 3 over negative 1. So we would end up with 3 as our y-intercept. And we didn't cancel anything, so therefore there are no holes. So anytime you simplify a function and nothing can be canceled, there are not going to be any holes. All right, for b, we are going to have to simplify this function. So we're going to start off by factoring the top. When we factor the top, we get x plus 1 times x minus 1 because we have a difference of squares. On the bottom, we get, well, first of all, we can take a negative 2 out. If we factor out a negative 2, that leaves us with x squared minus 3x minus 4. And so if we factor the bottom, let me go ahead and write the top again because nothing's changed in the top, it's already factored. So what we get in the bottom is, this will actually factor down into x plus 1 times x minus 4. Now, you'll notice that the x plus 1s can cancel. So our simplified function is going to be y equals x minus 1 over negative 2 times x minus 4. Okay, let's talk about the horizontal asymptote. I think it's easier if we go to our original function for this, okay? Our highest power on the top is 2. Our highest power on the bottom is also 2. So our number in front of x squared is 1 on the top and negative 2 on the bottom. So we have 1 over negative 2. So our horizontal asymptote is y equals negative 1/2. Our vertical asymptote is where x is 0 and the bottom of our, where we make the bottom 0 in our simplified function. So what value of x does that? 4 does. So x equals 4 is our vertical asymptote. Our x-intercepts, what makes the top 0? X equals 1. For our y-intercept, if we put 0 in, you can put 0 in either for the simplified function or the original. Here I think the original is easier because if you put in 0 for x squared, you get 0, so you're left with minus 1 on the top. On the bottom, the first two terms become 0, so you're left with 8. So you have negative 1 over 8, so our y-intercept is negative 1/8. And then for our holes, we want to get a coordinate pair for this, okay? So in order to do that, first we got to find what our x value is. Well, go back to when we factored everything before we canceled. We canceled out the x plus 1. What makes the bottom 0 for this term? X equals negative 1. So we know our x value is negative 1. You could then take your x value and you plug it into your simplified, okay? So you're going to end up putting it in here, negative 1 minus 1 over negative 2 times negative 1 minus 4. You cannot plug it into the original because that's going to give you 0 on the bottom. You have to do it in your simplified function, okay? When you do this math, you end up with your y-coordinate being negative 1/5. And so that would be your hole. All right, now let's talk about C here. We've got 4x plus 4 over x squared plus 6x plus 5. So we're going to have to factor the top and the bottom. So on the top, we end up getting, when we factor out the 4. So we get 4 times x plus 1. On the bottom, we can factor this down to x plus 1 times x plus 5. So the x plus 1s are going to end up canceling. So our simplified function is going to be y equals 4 over x plus 5. So our horizontal asymptote, again, let's look at the original equation because I think that's the easier one to look at. Our biggest power is on the bottom. So when our largest power is on the bottom, Our horizontal asymptote is just y equals 0. Vertical asymptote, we look at the bottom of the simplified. What makes the bottom 0? X equals -5. All right, x-intercepts. Well, there's no value of x that's going to make the top 0, so there are none. And if you think about it, it makes sense that there are no x-intercepts because our horizontal asymptote's at y equals 0. So our asymptote is along the x-axis, which means we should never cross the x-axis, which means there are no x-intercepts. For a y-intercept, we plug in 0 for x. I think it's easier to do here in the simplified. If you put 0 in here, you get 4 over 5, so 4/5. And then finally for the whole, we have one of them at x equals -1. If I put in -1 for x here, -1 plus 5 is 4. 4 over 4 is 1. So your y-coordinate for the whole would be 1. On to example D. We're going to factor the top. So we're going to factor out a -4, and we get x minus 1. On the bottom, we're going to factor and get x minus 1 times x plus 3. And so that gives us a simplified function of y equals -4 over x plus 3. Our horizontal asymptote, our bigger power again is in the bottom, so we have y equals 0. What makes the bottom 0? X equals -3. X-intercept, nothing in the top. There's no value of x in the top that would make the top 0. And again, our horizontal asymptote's at y equals 0, so we have no x-intercepts. Y-intercept, put in 0 for x, you get y equals -4/3. And for our wholes, x equals 1 from what we canceled on the bottom. And when you put in 1 for x here, you get -4 over 4, which is -1. All right, for example E, we have on the top, we can factor into x minus 2 times x plus 4. The bottom, we can factor a 4 out, and that gives us x minus 3. So as it turns out, there's nothing that we can cancel in the top and the bottom, so our simplified function is x minus 2 times x plus 4 over 4 times x minus 3. Our horizontal asymptote, we are going to have the value, well, we're going to look at the degree, okay? The highest power on the top, there's not an x squared on the bottom, so our highest power is on the top, which means we do not have a horizontal asymptote. Vertical asymptote, we look at the bottom, highest, or the value of x that makes the bottom 0 is 3. Again, always looking at the simplified function for that one. X-intercepts, well, the top, we have two values of x that are going to make the top 0, those being -4 and 2. Y-intercept, if we put in 0 for x, and I think here it's easier to go to our original equation. If we put in 0 for x, we get -8 on the top, -12 on the bottom, so we get positive 8/12, which reduces down to 2/3. And for our wholes, since we didn't cancel anything, there are no wholes. And then example F. Let's start by factoring the top. So we have x times x squared minus 3x minus 4. We get that by factoring an x out. On the bottom, we can factor a 3 out. That gives us x squared minus 2x minus 3. And now let's factor the trinomial on the top. So that gives us x plus 1 times x minus 4. On the bottom, let's factor that trinomial. That gives us x plus 1 times x minus 3. And so we cancel the x plus 1s, and our simplified function is x times x minus 4 over 3 times x minus 3. So our horizontal asymptote. We're going to look at the highest power on the top, highest power on the bottom. Our higher power is on the top, so therefore we have no horizontal asymptotes. Our vertical asymptote, the bottom is made 0 when you have x equals 3. For our x-intercepts, we have 2 of them. So for our values on the top, our values of x on the top that make the top 0, you have 0 and 4. That's 0 coming from that leading x. For the y-intercept, we set x equal to 0. Well, let's do this in the original. We have 0, 0, 0. So on the top, we're just going to end up with 0. 0 divided by anything gives us 0. Y equals 0. And then for the wholes, we canceled out the x plus 1. So our x-coordinate is going to be negative 1. And again, if we put in negative 1, and I'll show you this one more time, if we put in negative 1 for x in our simplified, that is how you get the y-coordinate. So if you do that math, you'll end up getting negative 5/12 as your y-coordinate. So now that we know how to pick out some key features, let's just go over some of the steps for actually producing the graph. So to produce a graph from those key features that we just found, first you're going to take your vertical and horizontal asymptotes and you're going to plot those. Then you're going to take your x and y intercepts and you'll plot those. Then you're going to make a table for several x values that lie on either side of the vertical asymptote and between the x-intercepts, and you'll plot the points from your table. Now don't forget, take that point for your hole and plot an open dot for that, okay? That way when you draw your line through, you have an open dot where your hole is. And once you have your points all plotted, then you're going to sketch your graph. So that's really all there is to it. The one challenge you may find is having to plot the points from your table, okay? And when you plot points from your table, basically all you're doing is taking some x values and you're going to put those x values into your original function to find out what the y is that goes with that x. That'll give you a set of ordered pairs to do a plot. And you'll have to do this a few times so you can get a good idea of how the graph should be sketched. You do have to be a little bit more specific when you're graphing in this case, because we do have holes and things like that, and y and x intercepts. So you want to make sure you hit those marks specifically. Okay? But you can do the graph, and again, doing the graph in this class will be an extra credit item for you. All right, that does it for this section. The main thing here was to identify some of those key features, your asymptotes, your intercepts, and where your holes are. In the next section, we are going to solve rational equations.